Okie dokie. Today we are starting a new unit, new U. We are going to multiply and divide rational expressions. Raise your hand if you did the homework from last class. It was a review. Sort of, a little bit. It was factoring. If you did, give yourself a pat on the back because good for you. The steps to multiply or simplify rational expressions. So, also, I'll pause for anybody that would like to get up and get a highlighter. She might need one today. You're welcome to use one of mine, or you can use yours. So step one will be to factor. Step one will be to factor. We have to factor the numerator and the denominator. The numerator is the top and the denominator is the bottom. Step two, it will be to set the denominator equal to 0. And we're going to find values that make the expression undefined. These are also called domain restrictions. So if you're undefined, they are domain restrictions. And the domain restrictions are most often x is not equal to something. Can you divide by 0? What happens if you divide by 0? Type it in the calculator, see what the calculator tells you. I don't know, type it in, what does it say? What does it tell you? No, it doesn't. Because we can't divide by 0. They're undefined. They're domain restrictions. That's why we're doing this. Next, we will divide out common factors. I think that when I say that, you probably think of it as like canceling. Or reduce. We will multiply straight across, and then we will double check to make sure that it is fully simplified. So let's do some examples. The directions say to simplify and state any domain restrictions. So domain restrictions are things that we have to check the denominator. So I'm going to do that first. When I look at the denominator, things that would make my denominator equal to 0 are things like if x was equal to 0, because if I multiplied by 0, it would all be 0. Y also can't be 0, because if it was 0, that means it would all be 0, and we cannot divide by 0. So my domain restrictions for A, x cannot be equal to 0, and y cannot be equal to 0. So anytime you're dealing with things and they look like that, like, do you see how A and B are different? When you have a monomial in the bottom. So when you look at answer choice D, it would be the same thing. Or sorry, example D, it's the same type of problem. Okay, so we did our domain restrictions. And now we're going to simplify. This is like what we did on the notes, or sorry, on the warm-up kind of. So with these, if you know how to reduce, it's not a big deal. You reduce the fraction. Most likely you're going to have one of these calculators on any assessments we have. They can only help you so much. And so I don't really care if you use the calculator to help you, or one thing that we're doing is actually factoring things out. If we factored out 10 and we thought about what makes 10, it's the same thing as 2 times 5. And I have x to the 8th, but to the second power. What makes 6? It's 2 times 3. We have to look on the top and the bottom, and this is step 3. We're looking to see if any factors divide out, because what's 2 divided by 2? 1. So anything over itself becomes 1. And with my exponents, I will always subtract towards the bigger one. So when I look at the x's, I have 8 and 4. 8 is bigger, so it's like a magnet. It's going to pull this one up and you subtract. So this will go up there and I subtract 4. When I look at these exponents, 3 is bigger than 2. So this one will cancel and come down here and I will subtract 2. So what do I get? I write down what I have left. On the top, I have a 5. And then I have an x, and it was 8 minus 4, so to the 4th power. On the bottom, I have a 3. And then y, and then it's a 3 minus 2, so it's just to the 1st power. That is it. And I have to also include my domain restrictions. For the second problem, I was nice and I factored it all for you. So first step done, it's factored. Second step is checking for domain restrictions. So domain restrictions are anything that would cause a 0 in the denominator. And so if I wanted this factor, if it was a 0, the only way I can make 0 is if it's a 1. What's 1 minus 1? So x cannot be equal to 1. What would make this factor 0? 5. X cannot be 5 either. So we did step 1, it's factored. Step 2, we checked for domain restrictions. Step 3 says we're going to divide out any common factors. Are there any common factors? Any factors that are on the top and the bottom? Yeah, I see one, this one, and that one. Anything else? Nope. So we can reduce. So we get x minus 3, or clean it up. And that's all we can do. For part C, am I fully factored? No, the denominator is not factored. And so this is part of what I asked you to do on your assignment. So the denominator needs to be factored. The numerator is factored. I'm good. To factor the denominator, I know that I'm going to have 2 factors with x and x. And I'm thinking of things that can multiply to give me 8, that can put together to give me 6. What can multiply to give me 8 that can put together to give me 6? 4 and 2 work. My middle number is positive, so the bigger number needs to be positive. And if I have 4, I would have to add 2. to get to 6. Say I am factored. Now I can state any domain restrictions. So x cannot be equal to, what would make the first factor equal to 0? So I have 4. How can I make 4 0? I would have to what? I'd have to subtract 4. And for the second one, how would I make this equal to 0? Do I have any common factors? It looks like I have x plus 2 and x plus 2. That's going to reduce to just 1. So I can write down what I have left. I don't care if you put parentheses around them or not. When you only have one factor, you don't have to. But if you have multiple factors, you definitely do. Okay, now we're going to move on to the big kid stuff. So the big kid stuff is that we're actually going to multiply. So the next set of directions say we're going to multiply, and we're still going to state domain restrictions. Domain restrictions are when the reason we do domain restrictions is because we can't divide by 0. Remember how much I really like to put those sentences on quizzes and tests and things? We need to know how to answer them. You have domain restrictions because you can't divide by 0. So for my first example where I'm multiplying, what would make either one of these denominators equal to 0? If x was equal to what? Can x be equal to 7? If x is equal to 7, that would be 7 to the third power. Is that 0? No. Okay, so can x be equal to 1? 1 to the third power, is that 0? No. Okay, then what can x not be equal to? 0. What can y not be equal to? 0. Y cannot be equal to 0 either. These are different. They don't have factors. When you have factors like this, it's easy to see what x can or cannot be equal to. When they're like this, that's what I was saying. It's always x is not equal to 0. Just an x by itself that isn't in parentheses will always be x can't be equal to 0. A y by itself, not in parentheses, it's always y cannot be equal to 0. For these, I can also list out factors. If you need to do this, that's fine. 3 is the same thing as 3 times 1 or just 3, so I don't need to really reduce that at all. Or sorry, or write it as factors. Same thing with 2. It's already factored. 10 is the same thing as 5 times 2. Nine is the same thing as what times what? I'm going to check for common factors. And so common factors are on the top and the bottom. So does anything match up with the 3 on the bottom? There's no other 3s on the bottom? There are. Is there any 5s on the bottom? Are there any 5s on the bottom? No. Are there any 2s? Yeah. All right, now I'm going to multiply straight across. When I multiply straight across, I have to add exponents. So across the top, I'm left with just a 5. And then for my exponents, I have a 5 and a 3. That makes 8 for the x's. For the y's, I have a 3 and a 4. That makes 7. In the denominator, I have just a 3. For the x's, I have a 3 and a 2. That makes 5. For the y's, I have a 7 and a 5. That makes it 12. Now I need to reduce my exponents. So I will always reduce towards the bigger one and I subtract. So when I look at the x's, I'm bigger on top. So the 5 will come up and I subtract 5. For the y's, it cancels on the top and it comes down and I subtract 7. So I end up with 5 and then there's an x. 8 minus 5 is 3. In the denominator, I have y. 12 minus 7 is what? So I have to include my domain restrictions. So you multiply and simplify. For the next problem, am I fully factored? No, I am not fully factored. 1 over x, that is fully factored. That's fine. When I look at the top, I have 8. And so for some of you, you might need a piece of scratch paper to be able to do your factoring. So for the top, the numerator, I'll do it down here at the bottom so you can see what I'm doing. I have 8x cubed minus 2x squared. There is a GCF. I can factor out a GCF. What can divide into both of those? 2. What about any x's? Two x squared. And if I factor that out, it gets written in the front. And I'm left with 8 divided by 2 would be 4. 3, 2, 1, I have 1x. 2x squared over 2x squared just becomes 1. Okay, I can put that back. In the denominator, I have a 4 and then an x minus 1. In 2 over 4, can that reduce? Yeah, it's the same thing as 1/2. All right, if I multiply straight across the top, I get 1 times x squared times 4x minus 1. Oh, I forgot to list my domain restrictions. X cannot be equal to, for this first one, what can x not be equal to? Okay, can I divide by 1? Yeah, I can divide by 1. So what can x not be equal to? Cannot be equal to 0. So x cannot be equal to 0. Anytime you have an x by itself, cannot be equal to 0. Over here, I have a 4. There's no x there, so it doesn't matter. What can x not be equal to here? Oh, okay. I think somebody might have been saying x cannot be equal to 1 for this factor. Is that what you're talking about? I think somebody said 1. Were you talking about this factor? Yeah, you're correct. X cannot also be equal to 1. Sorry if you were just ahead of me. When I multiply straight across the top, I get x squared and then 4x minus 1. In the denominator, I am left with a 2. There's an x. And then x minus 1. Oh man, I forgot. I didn't see that we could still reduce. We've got an x and an x. Okay, I see it here though. So if I have x over x, one of those will pair up. So 1 cancels. I got to rewrite it again. So on the top, I have x and then 4x minus 1. In the denominator, I have 2 and then x minus 1. Again, some of you may need scratch paper because some of these take up room. For example, f, is it fully factored? Nope, because it looks like that denominator can be factored. Most everything's factored, but it's not fully factored. So I still have to factor that denominator. To factor the denominator, I have to come up with 2 things that can multiply to give me 8 that can put together to give me 6. What 2 things can multiply to give me 8 that can put together to give me 6? Yep, 2 and 4 work. My middle term is negative, so it needs to be -6. And if I have -4, I would have to subtract 2 to get -6. I need to state my domain restrictions. X cannot be equal to, for my first factor, that's going to be +2, +4, -5, +7. So I'm going to list them all. And then I'm going to look for any common factors. Does x minus 7 match up with anything on the bottom? I see it over here. So that has a pair, I can mark it off. The x plus 3, does it have a pair? Nope. X minus 4. Yeah. All right, then I write down what I have left. All right, I'm giving you 5 minutes to look at the front side of your homework. You are free to talk to your people. We're going to try some of the problems on the front side of the homework. All right, hopefully some of you took the time to actually start your homework. On to the back, steps to dividing. The steps to divide are very similar to the steps to multiply. We also have to factor. We have to set the denominator equal to 0. To find values that make the expression undefined. Why do we have to check for things that make the expression undefined? Why do we have to do this? Because you can't divide by 0. So since y'all couldn't tell me why, you need to write it down. You can't divide by 0. We have to do this in the beginning and we have to do it in the end when we are dividing. For division, we will rewrite as multiply. And we will do KCF or earlobe method. KCF is keep, change, flip. We will keep the first fraction. We will change to division. To multiplication. And then we will flip the second fraction. And then once we have multiply, we will multiply straight across. The earlobe method doesn't help a whole lot when you're doing fractions like this. It helps more when you're doing things like on your homework. But the earlobe method tells us the things that are going to go together. So it kind of looks like an earlobe. The top will go with the bottom and then the middle will go together when you flip it. But keep, change, flip is very similar. So we will keep the first fraction the same. We will change to multiply and we will flip the second fraction. Now, as I go to multiply, it's easier if you try and reduce things if possible. I noticed that I have 8 over 8, so those can reduce. And then I noticed that I have a 15 and a 15 and 5. So 5 goes into 15 3 times. So that will become 1, and this becomes a 3. And then I will multiply straight across for my exponents. So I have x to the 4th, y to the 5th, over x squared. Oh, there's a 3. 3x squared, y squared. And then I can't have x in the top and the bottom, so I have to reduce. It looks like that I'm bigger on the top and the bottom. So that 4 I will have to subtract 2, and that 5 I'll have to subtract 3. So I get x to the second power, y to the third power. And I'm only left with a 3 on the bottom. I'm not done yet though, because I have to state my restrictions. So my restrictions, x and y, can both not be equal to what? 0. For part B, I have to first factor. I can't do anything until I factor. And this is one that is often overlooked. That's a difference of perfect squares. That's also a difference of perfect squares. They're going to be all over the place. You need to get good at spotting them because they are all over. So x squared minus 1 is the same thing as x minus 1 and x plus 1. The denominator is already factored. The numerator of the second one is already factored. This is another difference of perfect squares. 16 is the same thing as 4 squared, so I put a 4 and a 4. One needs to be plus, one needs to be minus. I have to identify any domain restriction, so anything that's in the denominator right now. X cannot be equal to +1, +3, and positive and negative 4. I can't do anything until I keep change flip. I have to keep change flip. I have to keep the first fraction the same. I have to change to multiply. So keep the first fraction the same. Change to multiply. Now I'm going to flip the second fraction. Flip the second fraction. Keep, change, flip. Now I'm going to check for any, my second fraction, I have a new denominator, so I have to double check. Do I have any new factors that can't be equal to 0? I already have -4. Oh, I don't have +2, so I have to add that to the list. So anything that is ever a denominator in your problem, you've got to check for zeros. Now I can mark off any common factors. So I automatically see the x plus 1 or x minus 1. I see an x plus 4. Do y'all see anything else that cancels? Hello? Hello? Well, I don't know why they're both show up for me, but it's mine and Logero's, I believe. I think Logero. No, I mean, I have students and he has students, but I don't know why I get both rosters. Hmm. Nope. Uh-huh. Bye. Do you see any other factors that cancel? Yeah, I got that one. I don't see any other ones either. So I am done. So I just rewrite it. X plus 1, not that. And that is my answer. This is fun math, right? Moving right along, we're dividing, so it's probably going to be helpful for most of y'all to write these out. As I write it out, I'm going to give myself a note that my denominator is the same thing as over 1. I can also go ahead and factor as I rewrite it. So in the numerator, what do you think can multiply to give me 4 that can add to give me 4? Before I keep change flip, I have to check for domain restrictions. What can x not be equal to? So I only have 1x in the denominator. So what would make this denominator 0? Now I can keep change flip. I keep this first fraction the same. I change to multiply and I flip the second one. And then I check for new domain restrictions. So what cannot make this denominator equal to 0? It looks like I've got one common factor, so I mark it out. And that is my answer. You might want to give yourself a note that what we did was keep, change, flip. That's how we got there. For the last problem on the notes, I need to factor everything. Nothing is factored, so I have to first factor everything. That numerator is kind of ugly, but it looks like it can all divide by 7. So if I divide it by 7, 7 or 27 divided by 20, 28 divided by 7 would be 4. That would be a 3. So that will be easier to factor that way. Two things that can multiply to give me 3, 1 and 3. The middle term is positive, so the 3 needs to be positive. And I would have to add 1. The denominator is a difference of 2 squares. So I would have an x and an x. Plus 2 minus 2. My numerator looks like a GCF. They both divide by 7, so I can divide out a 7 and be left with x plus 3. Two things that can multiply to give me 18. They can put together to give me 7, 2, and 9 would work. 7 is positive, so the 9 has to be positive. If I have 9, I would have to subtract 2. Hello. Who's your friend? I don't know who that is. Do you think it was this classroom? Is there might be a Chromebook charger right there at the front of the room, right here. Right here, plugged into the front wall. You can turn it on. It slides, slide it to the middle. Is that a charger? Is that yours? Okay, awesome. I have to list all the domain restrictions. Yeah, at the bottom. So X cannot be equal to 2, -2, or -9. I can keep, change, flip. I have to keep the first fraction exactly the same. Gonna change to multiply and flip the second one. For this one, I would like for you to look at your paper and see if you can figure out how to cancel anything out or to divide out common factors. That's it. I forgot to check right here. This was another denominator. I can't have X equal to -3. Now I'm done. That is all of our notes. This is pretty boring stuff. It is.